Welcome back. So this one is for pre-cal honors. So I just want to go over some of the concept that you guys did in Algebra 2 honors. And some of the stuff that in Chapter 1 of pre-cal honors, they're almost identical as the one that you learned from Algebra 2 honors. But there are certain things that they consider probably like brand new for some student as well. So we'll start doing that. Well, the first type of problem is just like using the point slope form and then finding that the new equations for the line and then using that to find the x-intercept. So this one is actually pretty basic. So it's just like going back to Algebra 1. But this one is being generated from like either decimal or some kind of computer software. So there's like a family equation given. And you want to find out the value of k and also find out the common point, every line that they share in common. So this one, I just want you to think about it and use that as like a critical thinking problem. So let's start with some of the basic stuff like factoring. So anytime that you try to factor things like this, you always want to check the greatest common factor. If that's a binomial, so most likely it's kind of like a difference of 2 squared or the sum of 2 cubed or the difference of 2 cubed. Okay? But the things that if that's like a higher power, always, so take out the greatest common factor first. And then for the rest of that, you can either use the cross method or the smiley face. So let's do some of the rigorous problem. So the one that I would like to pick, it's E, problem 2E right here. Okay, so we'll take a look at that. Okay, let me just connect this one back with the tablet. Okay, so what we got for 2E, so we started off with 6x to the power 5 minus 21x cubed minus 12x. So the first thing that I want to check out is the greatest common factor. So we got 6, 21, 12. So that means all those numbers, they're all divisible by 3. So take out 3. And also things that they share in common, it's x. So take out 3x. So what's left here, it's just 2x to the power of 4 minus 7x squared. And then minus 4. And then from here, for the trinomial, we do know that it's a 4th degree trinomial. So basically we can factor the trinomial by either using the smiley face or the cross method. So let's use the smiley face approach and see what happens. So we do know that the number here in the middle is -7. So in order to come up with the product of the sum, it's -7. So this one, I would like to break it apart into 2x squared and then x squared. And then -4, I would like to use 1 and -4. So checking the words, so in the product, so we do have 1x squared. Out of the product, we do have -ax squared. So eventually, then that'll be -7x squared. And that just satisfies what we have here in the middle. So the way to pair this up, okay, so let's just carry this one over. So the greatest common factor, just take that, carry that over. And then whatever that we have on the left-hand side of the factor tree under the i's, so we just want to group those number and the elements together. So 2x squared plus 1, so just group those two terms together. And then x squared minus 4, so whatever that we have on the right-hand side of the factor tree, also group them together. And now, for those you might be wondering, is this the simplest factor form? Well, it looks like it, but the thing is that x squared minus 4, that shows the pattern of difference of 2 squares. So we want to factor it again. So this one can be written as x minus 2 and then x plus 2. So for the final factor form. Okay, so now let's take a look at that, the one with the quadnomial. So normally for the quadnomial, we want to group the like term first. So for C and F, those are the quadnomial 4 terms. Okay, so let's see, for C, so let's start it off with x squared y. And then let's just pair this one with that axy. Again, whatever the one that they have something looks kind of in common, so those are the one you want to group them. You want to group all those terms together. And then the other one we got here, it's negative a, negative x. So let's put in this one, negative x, negative a. So we do know that addition is always considered commutative, so we can swap them around. And now for the rest of this, so we want to take out the greatest common factor of the first group. Okay, so the greatest common factor of the first group, so then that would be considered xy. So what's left here, it's x plus a. And then what about the second group here? So things that they share in common, Well, that's just -1. So that means we take out x and, well, just leave that x in positive a. So for the common binomial, we do have x plus a, so keep it that way. So x plus a, and then whatever that's remained, so we got xy minus 1. Okay, so then that'll be the final factor form. And anytime that you show the word, make sure that got to be consistent. So set up the equal sign, and then the equal sign. And now, what about for f? Okay, so for f, that's quite similar. Okay, so let's look at that one. So for f. And for f is also considered a quadnomial. It's a quadratic quadnomial. So again, first things that you want to do, you want to group those like term. Well, it's hard to tell which one is considered a like term because that is x squared with y squared and minus a squared minus 2xy. So you try to do it like the way I show you with the binomial, the group like terms. So probably it's not going to work. So what you need to do, you want to group that x squared, y squared, and then negative 2xy together first. Okay, so let's put it in this way. So that's just considered a trinomial. And then minus a squared, we just want to separate that term. So one thing that we notice, x squared minus 2xy plus y squared. So once you factor it, it's a perfect square. It's a perfect square trinomial. So that means once you factor it, it's like x minus y quantity squared. And then minus a squared. And now from here, we do know that's the difference of two squared patterns. So this one is x minus y minus a. And then times x minus y plus a. So consider that x minus y, it's just like b squared. Well, b, so b squared. So this one is written as b minus a times b plus a. Okay, so you need to recognize the structure of those special formula for factoring. Okay, so now the next type of problem I would like to talk about here, it's about the properties of the exponent. So this one, you guys might be a little bit freaking out here. So pi to the power of a minus b, so you might be wondering what that means. So pi to the power of 2a plus b. Well, this one is just the structure of the rational exponents. So the same base, divisions. So what we can do, we can always subtract the exponent. So a minus b minus 2a plus b. So make sure that you put in the parentheses for the 2a plus b because you subtract the whole quantity. So not just that 2a or b separately, but you actually subtract the whole quantity. So that's why I put out the parenthesis here. So what we got here, so a minus 2a, so which is negative a, so pi to the power of negative a. Negative b minus b, so negative 2b. So negative, negative, this one you probably want to put it this way. So pi to the power of negative 1 times the quantity of a plus 2b. So take out the negative sign. And then negative exponent, so this one is written as 1 over pi to the power of a plus 2b. And that's the final form. And for those you might be wondering, what about that a is greater than b greater than 0? Well, this one is just give you the initial condition. So we do know that a and b, they're not 0. So they're just like one is greater than the other. And they're all considered positive, real number. Okay? So this one is kind of normal, like the way that we did it in Algebra 2. So this one you can figure out what that is. So now what about for the rational exponent? So 9 to the power of 3/2 over 3 to the power of 2/3. So 9 to the power of 3/2, this one can be written as square root of 9 to the power of 3. So if you do see anything like a to the power of n over n. So the structure for the rational exponent, it's considered nth root of a. So always try to reduce the number first before you enlarge it. Okay, so n root of a to the power of n. So square root of 9, which is 3 to the power of 3, so then that'll be 27. And now what about the denominator? The denominator is quite similar, but this time you probably want to enlarge the number first because we don't know what cube root of 3 is. So 3 squared, then that'll be 9. And then with that cube root, okay, so cube root of 9. Okay, like that. And then from here, you want to rationalize it. So multiply that top and the bottom by, well, in order to come up with a positive number without the radical. So you want to multiply this number by, well, let's just put it this way, 9 to the power of 1/3. So let's multiply by 9 to the power of 2/3. Okay, so 9 to the power of 2/3. So now this one is kind of getting a little bit more complicated because that you want to combine those 9, 27. So it looks like they have something in common. Okay, so we'll take a look at that. Well, 9 to the power of 1/3 times 9 to the power of 2/3, definitely that would be 9 to the first power because that's the same base multiplying. So that means we combine the exponent. So the denominator is pretty easy to take care. But the top part is a little bit crazy. So 27, it's like 3 to the power of 3. And then 9, this one can be written as 3 square. So let's put it this way. So 3 square for 27 times 3 to the power of 2, well, which is 3 square, to the power of 2/3. Okay, so you'll see that in a minute. So this one, 2 to the power of 2/3, which is what, 4/3. So 3 cubed times 3 to the power of 4/3 over 9. Well, definitely you can reduce down the number if you want to. So 27 over 9, then that'd be 3. Okay, so this one just reduce down the number. So 3 times 3 to the power of 4/3. So it's like 3 to the first power times 3 to the power of 4/3. So which is considered 3 to the power of 7 over 3. So you probably want to rewrite it. So this one, it's a improper fraction. So it's just 3 to the power of 1 and, well, actually 2 and 1/3. So eventually this one is written as 9 and then cube root of 3. Okay, so there's another easy way to do it. So come up with the same base first. So 9 is like 3 to the power of 3 to the power of 2 to the power of 3/2. Then that'd be 3 to the third power. And then basically from there you want to divide it. So another way you can do it for that one. So it can be written as 3 to the power of 2 to the power of 3/2. And then over 3 to the power of 2/3. So 2 times 3/2, so that would be what? 3. So 3 to the third power divided by 3 to the power of 2/3. And then from here you want to subtract, so it equals 3 to the power of 2 and 1/3. And then for the final part, you want to separate it. 3 squared, 9. And then 3 to the power of 1/3, cube root of 3. So that might be a little bit easier. So the first way that I show you, I'm sure a lot of students would be doing like that. You know, so try to simplify the top number first and then the bottom. But the thing is that if you're being able to come up with the same base using the properties of exponent and then subtract. So that makes it a whole lot easier and faster. Okay, so the rest of this, they're quite similar. So it looks like it's solving any kind of exponential equations and also the one with the higher power. Okay, so we'll take a look at that in some of the problem. Okay, so let's do number 6. Okay, let me just erase this one. Okay, so number 6 is showing that 2 to the power of a equals 3. So what's the value of a to the power of 2a? So this one is kind of like one of the classic SAT 1 or SAT 2 problem. So the given condition is 2 to the power of a equals 3. So a lot of people might be wondering, do I need to solve for a? I mean, if you try to solve for a, then that'd be a lot more work, okay? So this one, a to the power of 2a, can be written as 2 to the power of 3 to the power of 2a, okay? So we do know that this one is a power to another power. So another way to rewrite it, we do know that product, it's always considered multiplication, it's always considered associative, so we can swap those terms. So this one can be written as 2 to the power of 3 times 2a, okay? So now, we do know that 3 times 2a is the same as 2 to the power of a times 3 times 2, or times 6. Okay, so from here, we can just figure out that 2 to the power of a, which is what? 3. and then 3 to the power of 6. So it's like 3 times 3 times 3 times 3 multiplied by 3, 6 consecutive time. So which is what? 27 times 27. So 3 to the power of 3, then that's 27. So 27 times 27 is just like 27 squared. So just figured out what that is. So again, this one's kind of like a replacement. So 2 to the power of a is 3. So that's one thing we already know. So using that as like a substitution. And then 3 to the power of 6. So 3 times 3 times 3 times 3 times 3 multiplied by 3, 6 consecutive time. So 7 times 7, 49. 2 times 7, 14 plus 4, 18. 2 times 7, 14. 2 times 2, 4 plus 1, 5. So bring down, combine those numbers. And then eventually it's 729. Okay, so that's for sections 1.1. And now what about the rest of those problems? So those are the one basically you guys can figure out what to do. It's not that difficult. Okay, so for 1.2 is about the domain and the range. So consider the functions of y squared equals x squared plus 4. So let me just erase this one. It's kind of bothering here. Okay, so explain why the equation cannot represent a function. So going back to what we did in Algebra 2, so this one is kind of like a conic. It's like a conic section equation. So conic either like what? Circle, parabola, ellipsis, hyperbola. So y squared equals x squared plus 4. Okay, so let's find out the way to simplify that a little bit. So what happens if I just subtract x squared on both sides? So if I subtract x squared on both sides, so you might be wondering what kind of equation that is. And then divide everything by 4. And for those who do recognize that, it is the equation of a vertical hyperbola. So vertical hyperbola, it's always like this, while this one is just the parent function. Okay? So explain why this equation cannot represent a function. Well, because that once we do the vertical line test, as you can see that the dotted line, the dotted vertical line, it actually goes through 2 points on the graph right here. So anytime they see the vertical line that touch the graph at 2 points, going through, so that means it's not a function. Okay, so because we are not allowed to have a repeating x value. Okay, so x cannot be repeated or can be repeated. So let's say this one is x, comma y, and down here we do have x, comma negative y. So, well, we do allow to have the exact same y value, but the x value got to be different. If you see the exact same x value for 2 different y values, so that means it's not a function. So find a domain. So use both interval and inequality notation. So interval notations, I'm sure you guys know what that is, like parentheses, bracket, all that. And then inequality, another name for that is called the set building notation. So using less than, greater than, all those signs change, inequality. Okay, so now for the rational expression, because anytime they deal with the variable, we do have a rational equation. So that means the radical right here, well, the inner radical, so the content inside the radical got to be greater than 0. But one thing that we notice, if this one is in the denominator, so that means this whole quantity cannot be 0. So it's only can be what? Greater than 0. So x squared plus 4x must be greater than 0. Okay? So for the domain. And then from here, you want to solve for x. So we do know that this one, it's a quadratic inequality. So got to be very careful solving the quadratic inequality. Unlike the way that we solve for the linear inequality, we just want to isolate the variable. So anytime that I deal with the non-linear inequality, so what we can do, we can factor it first. So x, and then x plus 4 greater than 0. And then from here, you want to find out all the possible zeros. So x could be 0, x could be negative 4. And then you want to set up the table or the chart for the sine test. So negative 4, 0. Because normally this one can run through from negative infinity to infinity. So let's just find out the number you want to verify here. So let's say that you want to verify something such as -5, because that's less than -4, but it's greater than -infinity. Number right between -4 and 0, so let's verify that with -1. Any number greater than 0, so let's say that it's 1. So plugging that to the factor, so we do have two factors. So one is x, the other one is x plus 4. And then we want to find out about the result, whether that's greater than 0 or less than 0. So plugging -5, so it's negative. -5 plus 4 is also negatives. But negative times negative, it's what? Positive. So the result is positive, well, which is what we want, right? It's greater than 0, so it's yes. So for this interval, we'll find out a lot of solution here. And then what about for -1, right between -4 and 0? So negative, well, x, negative. -1 plus 4, positive. So negative times positive, which is negative. So this one definitely no, because we need to have something that's greater than 0. So what about 1? So 1, positive. 1 plus 4, positive. Positive times positive, positive, yes. So that means the domain for this one, according to the chart here, so showing that x, it's less than -4. And what else? X must be greater than 0. Again, for the final result, we need to end up with something that's greater than 0. So the way to put in for the interval notation is -infinity all the way to -4. Again, there's no equal sign, so that's why it's a closed parentheses. Union, what else? From 0, anything that's greater than 0, all the way to infinity. And that would be the domain. So this one, it's a lot more work. It's a little bit tedious because that we're solving for the non-linear inequality. Again, non-linear, that means the highest power, it's 2, 3, any other power other than 1. Okay? So this one is quite similar, but what about for number, for part C? So we do know that the cube root function is always given as this one. That's just the parent graph. It's kind of like a snake. It's like a sideways cubic curve. So regardless what happened inside the radical, if you deal with any kind of odd root, cube root, fifth root, seventh root, ninth root, so on and so forth, as long as the index number, it's an odd number. So that means the domain, it's always considered -infinity to +infinity. Okay? So now let's see what else that we have for the rest of this. So let's take a look at that, some of the word problem. So the circumference of a circle of a radius is equal to the perimeter of a square side length x. Okay? So express the area of the circle as a function of x. Okay, so we'll take a look at that. So the way to find the circumference of a circle with the radius is always considered 2 pi r. Okay, so 2 pi r. And then perimeter of a square, it's always considered 4 times x, perimeter. That means all the side lengths adding together. So 4x. So since we do know that they're equal, so 2 pi r equals 4x. So now express the area of a circle as a function of x. So instead of using r, we're using x. So in order to solve for r in terms of x, so we divide it by 2 pi both sides. So we do have radius, so that equals 4x over 2 pi. Excuse me for a second. Hey, can you guys be quiet a little bit? I'm recording right now. Okay, so sorry about that. I'm back. Okay, so now, after we solve for r in terms of x, so we're using the formula for the area of circle, which is pi r squared. And then we just plug in that 4x over 2 pi for radius. So we got pi times 4x over 2 pi, quantity square. Now for those you might be wondering, is that the form? Is that the final form? Well, we can simplify that a little bit more. Okay, so try to simplify that a little bit more. That means for the exponent, we just want to distribute. So we got pi times 16x squared over 4 pi squared. And then this one can cross cancel. Reduce. So eventually we do have the area of a circle in terms of x, which is 4x squared over pi. Okay? And now the next one, a box without the top to be constructed from a sheet of paper of dimensions 8 inches by 4 inches, okay, and square of the length x are removed from each corner. So write the equation of the volume of the simplest form as the functions of x. Okay, so we do have a piece of paper, the dimension with the length 8 inches, the width is 4 inches. Okay, so we'll take a look at that one. So started with the drawing here, so piece of paper. So the length is 8, the width is 4. And then the corner is being removed with that, the length, the squared length, x, okay, so the square length, x, like that, x, x. And here's x, x. And here's x and x. This one too, x and x. So write the equation for the volume of the simplest form. So now, anytime they want to fold the box without the top, so this one is going to be like this. So it's a rectangular prism. Okay, without the top, right? Okay, so that means the actual length for the box would be considered a minus 2x. And then the width would be considered 4 minus 2x. Well, because now you cut off the corner, x and x. And then the depth is just what? X. So write the equation for the volume. We do know the way to find the volume of a rectangular prism. It's length times width times height. So this one can be written as the quantity of a minus 2x times 4 minus 2x, and then times x. So state the range of the possible value of x. So that means you want to find out the possible value of the volume. Wait, the range of possible, well, this one is just the domain. I know the way it phrased it is kind of weird. So it looks like we're finding the range, but the range of possible value of x. Okay, so certainly we can take a look at that. So, well, that means x cannot be anything greater than 8. Well, because that won't make sense. That would be a negative dimension. And also, and x cannot be anything less than 0. Okay, if you try to think about that, because that x is just the height. Okay. So now the way to find out what that is, so we do have 3 possibilities here. You see the factor? So that means a minus 2x got to be greater than 0, 4 minus 2x got to be greater than 0, and also x got to be greater than 0. Okay, so 3 possibility. So started off with the volume must be greater than 0. Okay, so again, so solving for like a non-linear inequality, because the volume will never be less than 0. Can that be considered 0? Cannot be 0. That would be nothing. Okay, then there's no box right there. Okay, so that means we need to set up the chart like what we did earlier. So let's find out the possible 0 first, and then we try to verify that all the possibility. Okay, so let me just cross all this out here. So this one certainly you can do down the calculator, but what about without the calculator? How do you find out the domain? The value of x, all the possible value of x. So again, so we just want to use this one as like a non-linear inequality. So find out all the possible 0 first. So we do have x equals 4, and then x equals 2, right? If we set equal to 0, or x could be what, 0? But it got to be greater than. So again, cannot be 0. So started off here at 0, but 0 we cannot have zeros. And then what else? 2. Okay, kind of like a number line here. 4. And then again, the factor we have, so we do have a minus 2x. What else? 4 minus 2x. And then what else? X. And then the result. So just like the chart that we set up there earlier. So let's try to verify something that's right between 0 and 2. So let's say 1, using 1. So try to pick the easy number. Right between 2 and 4, so we do have, again, this one's got to be open circle, because that once you set equal to 0, that means there's no box. And 3. And then anything greater than 4, 5. Okay, so plug in 1, so we do have, again, the limit for this one would be considered 8, because you don't want to have x is greater than 8. Okay, so otherwise the length would be negative. Okay, so what we got here is it's a minus 2 times 1, so then that'd be positive, which is what? It's 6, right? And then plug in 1 for the second factor, so we do have 2, which is positive, and then 1, x, so that's positive, 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 so the result's positive. So this interval, so we do have the number from 0 to 2, that's fine. And what about at 3? So plug in 3, so we do have 2 times 3, 6. A minus 6, 2, positive. So 2 times 3, then that'll be what? Then that'll be 6. 4 minus 6, then that'll be negative 2. So negative. And then 3 is still considered positive, positive, negative, positive. Multiply them all together, negative. So this one, no. So again, the first part of the interval, yes. And now what about if I plug in 5? Well, this one definitely no, right? Because that 2 times 5, that's 10. A minus 10, then that'll be what? Negative. So it's going to fail. Because that's a negative length. And then what about 2 times 5? 10. Negative width. That's impossible. Well, this one is showing that is positive, but the thing is that somehow the length, the width, they're showing that it's negative. So this one, it won't work. Okay, so this one already tells you that no. There's no negative dimension. Okay, it's always positive. So that means for the possible range of the value of x, then that'll be from 0 to 2. No, from 0 to, yeah, from 0 to 2. Okay, so from 0 to 2, so let's put in with the interval notation. So again, anything that's greater than 2, it's not going to work, because that will end up with a negative width. It's going to be a negative volume. And then once we end up with a negative length, negative width, that's impossible either. So it's only from 0 to 2. So find x if the volume of the box is 192 cubic inches. Is this possible volume? Why or why not? Justify your word. Okay. So this one is something that we can think about. So 192, that means the maximum volume. So this part right here, you have to use a calculator for. Okay, so think about the other way around. So if this one is something that x is greater than, it's greater than 0, but it's less than 2. So that means the largest number for x would be what? 1.99 or 1.9. So let's say that's almost reached to 2. Okay? So 8 times 4, well 8. Well, let's just assuming that it's almost 2. So and then you plug in the number here. So we got 2 for the length, for the height. And then 2 times 2 minus 4, well, it's going to be very small. Okay, so again, this number is, it's almost 2, but it's like 1.9. So that means you want to find out the maximum volume for the box. Okay, so if is that possible? Or let's say that x is a very small number. Okay, so this one is something kind of interesting to think about. So normally we would like to do that on the calculator because this one is considered a non-quadratic or non-linear inequality. So try to put it into the decimal. You'll see that it's going to be like a maximum volume somewhere. Okay, so let me open it up with the decimal and see what happened for the range. So what we got here, so we do have the volume, so V equals a minus 2x, and then times 4 minus 2x. Okay, so the length, the width for the box, and then the depth. And you may be wondering, well, it is a cubic function, because once you multiply all the power, and now let's find out from 0 to 2, is that possible? Do you have a maximum volume as 190? Okay, so zoom it out or just drag the graph. See that maximum right here? So the maximum volume for this box, then that will be considered 12.317. Okay? So it's impossible. Okay, so we just find out the maximum volume for the box just by looking at the vertex of the graph. Okay? Okay, so now let's see what else that we have for this section here. Again, it's all about 1.2. And then the next type of problem, it's all about finding the quantity, assuming that non-zero denominator. So basically this one is just plugging that x plus h for x. So it's kind of like a direct substitution. So f of x equals 2x plus 7, so that would be written as 2 times x plus h plus 7. And then distribute, so 2x plus 2h plus 7. And then for the rational, so this one we can simplify that a little bit. So we got 2x plus 2h plus 7, the one that we did here already, minus f of x, so minus the quantity of 2x plus 7, and then all over h. So that means 2x got canceled, 7 minus 7 got canceled. Well, actually 7 minus 7. So this one got canceled after you distribute. So what's left here is just 2h. So 2h over h, then that'll be 2. So the setup here, this one is kind of like finding the rate of change. Okay, finding the rate of change or the slope. And then in calculus, the one that we'll be getting to next year. So this one is actually the derivative of this linear function, which is the slope of this line. So then that'll be 2. And then another way to verify it by using that f of x minus f of 2 over x minus 2. So this way you can do it on your own. And then what about for the quadratic? Similar. So find out that f of x plus h, and then you want to put it into that f of x plus h form, and then subtract f of x over h. So eventually the derivative of this one is going to be 2x. Well, let's find out what this first. So x plus h, quantity square, minus x plus h, and then plus 1. So what we got here, expand it, binomial expansion. So x squared plus 2xh plus h squared, minus x minus h, and then plus 1. And then this one we just want to put into the rational expression. So x squared plus 2xh plus h squared minus x minus h plus 1 minus this whole quantity. So x squared plus x minus 1 all over h. So you see that x squared got canceled. What else got canceled here? Negative x, positive x, the 1, negative 1. So what's left here is just 2xh plus h squared over h. So what we can do, so we can just simplify it. So 2xh plus h squared over h. Divided by h, top and the bottom, so we got 2x plus h. Well, normally we'll say that h goes to 0, but the thing is that this one, we just leave that with h. So eventually it's going to be 2x plus h. But in calculus, we're assuming that h is getting very small, and then eventually that the derivative or the slope for this quadratic equation, then that'll be 2x. Okay, so the next type is quite similar, but this one is a lot more complicated, so I'll let you to think about it. Okay, so 1.3 is about finding the increasing, decreasing interval for the function. So from the calculus textbook, it's showing that it's from either 1.4 or 1.5. So just check that page number. So strictly increasing, decreasing. So if functions f is strictly always increasing on the interval, if any two number x1, x2 in the interval such that x1 is less than x2, and then f of x1 is less than f of x2. Well, which is true. Okay, so x1 it's always less than x2, but you'll find out that f of x1 it's also less than f of x2. So if function f is strictly always decreasing on an interval if for any two number x1, x2 in the interval such that x1 is less than x2, but this time f of x1 is greater than f of x2. So strictly increasing, so x1 it's less than x2, but f of x2 is greater than f of x1. Okay, this one strictly decreasing. So it's kind of like exponential growth decay model or the logarithmic function. So if function f is increasing, non-decreasing, so in the interval if any two number x1, x2 in the interval such that x1 is less than or equal to x2, therefore f of x1 is less than or equal to f of x2. So like this one right here, increasing. Well, it's not strictly increasing because sometimes you see the little bump right here, okay? And it's called the point of inflections. We'll get to that in calculus. And decreasing, you'll see that it's not always strictly decreasing like the previous one. It's kind of like exponential decay or the log function. So it shows that a little bump right here. It's flat. So now let's do one example. Okay, so this one, so given that graph of f, so find the value of f of 0. So f of 0, this one is quite obvious, which is what? 4, right? And then f of 1, so which is right here, 1. F of 1, then that'll be -2. And then find the domain and the range of f. So the domain for this one looks like what? All real number, so -infinity to infinity. And then the range as well. There's no restriction. So it's all real number. And then determine the open interval where that f is increases and decreases. So increases, so then that'll be from 0 to 2. Okay, interval notation. And then decreases, then that'll be from -infinity all the way to 0, union. And then right here, decreases, then that'll be what? From 2 to infinity. If you know that f of x equals a times x plus b, so the X-Intercept Form, determine the value of a, b, and c. So the way that you want to set up this one, so let's say f of x equals a. Okay, so times x plus b. So finding the 0 here, so the first 0 would be this one, which is what? -1, so x plus 1. And then the other 0, so this one it's like a horizontal tangent. So that's why it happens twice. So then that'll be x minus 2, quantity square. And determine the value of a, b, and c. So using that point, the point that we have right here, the y-intercept, 0, 4. Plug in a number here and then solve for a. So b and c we already solved. So plug in a number, so we got 4 equals, well, the things that a times 0 plus 1 times 0 minus 2 quantity square. So we got 4 equals 1 times a, that's a, -2 quantity square, 4. So 4a, so that means a, it's 1. So right here we solve for b, because just by looking at the 0, the x-intercept. Okay, so b is -2. Well, actually, b, it's not -2, it's 1. Excuse me. Because this 0 here, it's -1. So -1 plus 1, that's 0. So b is 1. And then for c, okay, so the 0 here, then that'll be 2. Okay, so x minus 2, so 2 minus 2, quantity square, so that's 0. And now the x-intercept. So for c, it's considered -2. Okay, so this one is one of the classic example for the polynomial, something that we did from last year in Algebra 2 Honors. And the next one I would like to introduce here is the piecewise function. So piecewise function, it's always being broken into at least 2 pieces, the first half and the second half. So for the domain, x is greater than or equals 0, so we're using the absolute value function. So for the second piecewise function, so this one, that means for x is less than 0, so it's a trig function. So find the value of f of 2, while 2 is greater than 0, so that means we're using the first part of the piecewise function. So plug in a number, so we got 1 minus absolute value of 2, so it's 1 minus 2, which is what? -1. And then -2 pi. So -2 pi obviously is less than 0, so we're using the second one. So 2 times sine of -2 pi. So 2 times, well, sine of -2 pi, that's 0 on the unit circle. So 2 times 0, 0. And then for this one, g of x, right equations, So it's f of pi over 2 minus x. Okay, so for this whole thing. So basically for g of x, it's going to be a piecewise function again. So we're going to put in that pi over 2 minus x for the domain. Okay, so this one is going to be written as 1 minus absolute value of pi over 2 minus x. And then for the second one, similar, but it's 2 times sine of pi over 2 minus x. But don't forget one thing here, very important. It's about the phase shift, if you do recognize that. So this one can be written as f of negative times negative 1 times x minus pi over 2. So it shows like a reflections and also shows the phase shift. Okay, so this one, since we moved the graph pi over 2 unit to the right, so that means this one for the domain, we need to set up as the list of x is greater than or equal to pi over 2. And then this one, x is less than pi over 2. Okay, so this one's kind of interesting. So this one is linking to the transformations for the next section. So again, here's another piecewise function, so just make the graph. So using the table, anything that x is less than 2, so that would be a line right here. So start out with the y-intercept, 4. So negative 1 over 1, the slope. So down 1, 1 over to the right, down 1, 1 over to the right. But now this one, 2, it's not included. So this one will be open circle because that it's just like matching with the 2 right here. So this one is just like a decreasing line. So all the way to anything that's less than 2 for the x value. And then from here, anything that's greater than or equal to 2, so we're putting in the radical function. And you might be wondering, can we use the xy table to plug in a number to find out, you know, all the y value? I mean, certainly you can do it like that. But also at the same time, we can use transformation. So 1, 1, which is what? The y, the vertex. Okay, so 1, 1, which is the vertex. So without the restriction, normally it started right here, and it goes this way. So in order to get more points, so let's say that we put in 2. So 2 minus 1, that's 1. Square root 1, that's 1. 1 plus 1, then that's 2. So 2, 2. So that means the point, it's going to be right here. And then just connect it. And now let's find out more point here. So let's say we do have 5. So 5 minus 1, that's 4. Root 4, that's 2. 2 plus 1, 3. So 5, 3. So that means the graph is going this way. But keep that in mind, this one is only for x is greater than or equal to 2. So it just goes from here. So piecewise function. So one is linear, the other one is non-linear. It's a radical. So there are a lot more practice problems for the piecewise function. So that's something you guys can figure it out from here. Okay, so again, state the interval decreasing, increasing is G graph of functions. If there's no any repeating x value, or do the vertical line test, you don't see any point that's being intercepted twice on the vertical line, then that'd be a function. Okay, and here's another one, writing the equation of the piecewise relation. Well, this one is an interesting one. Let's try this. So it looks like we did 1, 2, 3, 4. Okay, so looks like we did 4 part of the piecewise function, but if you just count it, because this one's just a dot, so it doesn't really matter. So just 3. So this one set it up f of x. So start it off with anything that's less than or equal to negative 1. So anything that x is less than or equal to negative 1, we do have a straight line here, so that means what? Y equals 2. Okay, so we're just putting 2 right there, because f of x is already shown, so just putting 2. So for the first part of the piecewise function. And now what about the second part of the piecewise function? As you can see that the interval, this one is reading as from negative 1 less than x, it's less than or equal to 0. Because that is 0 here, this one is, it's a solid dot. Open circle, that means not included. So it's a straight line. If you try to continue with this one, so what is that? It's just a slope intercept form. So the y-intercept is negative 1, and the slope, if we count it, down 2, 1 unit to the right. So it's negative 2. So negative 2x minus 1. And then here's another piecewise function. So another piecewise function here. So this one is showing that it's from 0. It's less than x, but it's less than 1. Okay, so, well, it is right. It's actually 4 part of the piecewise function. 1, 2, 3, and also the solid dot. That's the separated function. Okay, so what we got here, it's another straight line. So that one is just y equals x. So that's just x, because the slope is 1. And the y-intercept is 0. Without that, the open circle, if we just count it, it's 0. So x plus 0, or just x. And then the last part of the piecewise function, so what is it? Y equals 2. Well, this one's supposed to be y equals negative 2, because that's underneath. And then the other one is up here, so y equals 2. That's just a dot, so the restriction for the domain, it's just x equals 1. So 4 part of the piecewise function right here. Linear, 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 and this one, it's just a dot. So to verify the odd-even functions, so the way to verify it, if the function is even, so that means f of x is always the same as f of negative x. If that's even. If that's odd, so that means f of negative x is always the same as negative f of x. If none of this is true, that means the function would be neither odd or even. Okay, so that's how we verify this type of function, right, for a and b. Okay, so let's do 1. So it looks like this one, f of negative x. So 2 to the power of x, negative x, plus 2 to the power of negative x, all over 2. So you may notice that this one is the same as the original ones. So 2 to the power of negative x plus 2 to the power of x over 2. So this one is even. Okay, so what about this? By looking at the power, 1, 2. So it looks like this one would be neither, but let's just verify it. So negative x over negative x quantity squared plus 4. So we got negative x over x squared plus 4. And now what about if I take the negative sign out? So this would be negative 1 times x over x squared plus 4. So this one would be considered odd. Yeah, it's kind of weird. You know, the power here, it's odd, but the power down here is even. So that's why you need to verify it if that's a rational expression or the rational function. So f and g are even and odd functions respectively. So f is even and then g is odd. Determine whether h is even, odd, or neither. Okay? So this one is one of the interesting one. So let's say that we do have an odd function. Well, even function first, and then an odd functions. So what kind of outcome is going to be? Is that going to be odd, even, or neither? Well, it's all depends. So let's say that we do have even functions for f of x. Let's say that's x squared, because that's a parabola. And then g of x has odd functions. So then that would be considered minus 2 times x to the power of 3. So I'm just making the example. So let's say that one is even, the other one is odd. Now what happened eventually? Would that be considered odd, even, or neither? Well, definitely this one would be neither. Because part of it, it's even, the other part of it, it's odd. And this one is just considered subtractions. So there's nothing we can do with the power. Okay, so that's why this one would be considered neither. So number 8, that one is just like a geometry problem. So I just want you to think about it. Okay, so a 5-foot tall man is moving toward the straight line that is x feet tall. Okay. So here's the straight line. So this guy's what, 5 feet tall? Kind of short. So what's the length L of his shadow? In terms of x, when he's 12 feet away from the light. Okay, so 12 feet away from the light. So kind of like a two similar right triangle here. Describe the shadow as x varies from 10 to 20 feet in length. Okay, so triangle, another triangle. Okay, so let's see for x, in terms of x. Oh, the straight line's x feet tall. Okay, I was wondering. Okay, so now we do have two similar triangle here. So one is a small one, so created by the man. So 5L. And then the other one is a large triangle created with the straight light. Okay, so this one is L plus 12, and then X. Right triangle, right triangle. So basically this one we can set up the proportionality. Okay, so this one's 5 over L, so that equals X over L plus 12. Describe the shadow as X varies from 10 to 20 feet in length. So basically just plug in a number and then find out the change. Okay, so this one is nothing special. And then the rest of this is just the review for the property, absolute value, piecewise functions. Okay, so absolute value of a minus b is the same as absolute value of b minus a. Just finding the positive distance from left to right, which is the same as the distance from right to left. The product, expand it, separate them. Quotient, separate them. Okay, so the rest of this is pretty straightforward, but actually you have to put it into the piecewise function form. Yeah, like the absolute value of x, so it can be written as x for x is greater than 0 for this part. Negative x, going this way, is for x is less than 0. It's a V-shape piecewise function. So use the definition of absolute value to show that x is less than 0 when the negative square root of x squared equals x. So this one is one of the good example. So what we got here, so negative, if just try to put in square root of x squared as absolute value of x, because this one guaranteed that it's always absolute value of x. Okay, so one thing that you notice, so this one is always true, making sure that it's positive. But the things that once you undo the absolute value of x, this one could be positive or negative. So for the negative, because x is negative, so negative x. Negative times negative, then that'll be positive. Okay, so that's how you show the word. And then the rest of this, write the following function as piecewise functions, clearly identifying the turning point. Okay, find out the turning point. So you want to find out whether that's positive, negative, all that. Okay. So let's do one example. So the turning point. So this one, the turning point would be right here at 2, because you'll see the absolute value, the turning point there. So it's being shifted 2 unit to the right. Okay, so I would say that for the piecewise function. So once you undo the absolute value, it could be plus minus x minus 2. So x plus x for the positive, then that'll be 2x. Okay, so separate it. So 2x. Again, using the positive first. And then positive times negative. Let's do negative, minus 2. So this one is for x is greater than 2. And then what about x is less than 2? Okay, so one thing I just want to check here. The absolute value, yes. Greater than or equal to. And then x is less than 2, so then that'll be x. And then negative x, so negative x and negative x got canceled, so then that'll be 0. Negative, negative 2, then positive 2. So that would be just a straight line right there. Okay? So this one's quite similar, the turning point. So it looks like one is at negative 1, and the other one is 2. And for those you might be wondering, how do I find out the turning point? So simply set the quantity of the absolute value equals 0. So you find the turning point. Okay? And this one, the turning point, it's right at either negative 3 or positive 3. Well, let's find out. This one we can swap them, so it's absolute value of negative x minus 3 all over x plus 3. So this one, the turning point, is for x is less than or equals to 3. So this one you got to be a little bit careful the way to find the turning point. Because once I swap them, so this one is written as negative 1 times x minus 3, so negative, negative, positive, but nothing we can reduce. They're not considered identical. Okay, so think about this one. And this one is one of the classic example. So this one shouldn't do it. It's plus minus, absolute value, quantity of x minus 1. Okay, let's see right here. Over x minus 1, so once you reduce it, so it's plus minus 1. So this one, separated out, g of x. So positive 1 is for anything x is greater than 1. Greater than or equal to 1. And then negative 1 is for anything x is less than 1. Okay, so solving absolute value equations, so that's linear, so that means you just want to separate the absolute value quantity and then just separate it out with positive, negative. So let's do one example. So this one, subtract for both sides, so we do have negative absolute value of 1 minus ax. So that equals negative 10. So negative, negative got canceled. So we left with absolute value of 1 minus ax. So that equals 10. And then break it apart, positive, negative. So going back to what we did in Algebra 2. So 1 minus ax equals 10. And then 1 minus ax equals negative 10. And then you just want to solve for x. And the other one, this one is quite similar. So x. Well, this one got to be careful. So it looks like we can factor out x first. Okay, the other side is what? Negative 9. Okay, so just undo the absolute value of x right here. So it could be positive, negative. Okay, so started with the positive. So that means we do have x times x, which is x squared, minus 6x. So that equals negative 9. So solve for this quadratic. And then if x is positive, so this one's for x is greater than 0. So x is less than 0, then that means we do have negative x squared minus 6x equals negative 9. So it's going to be like two different factors. So x squared minus 6x plus 9. So that means x minus 3 quantity squared. So x equals 3, and the multiplicity, which is what? 2. Because that appeared twice. And then this one's similar, so negative x squared minus 6x plus 9. Divide negative 1 on both sides, so we do have x squared plus 6x minus 9. Well, got to be careful with this part right here. Looks like this one is non-factorable. Positive 6, negative 9, using the quadratic formula, so it's going to be two imaginary solution. Okay, so check this. Imaginary solution. And then the rest of this, it's all about the compound inequality, but this one is the non-linear. With the absolute value linear inequality, it's pretty easy to solve. And then for the non-linear, so we have to do the Sine Test once again. All that. So we'll get to this one next time. Okay. So let's just stop this one here, and then the second half, I'll be doing the other part of the video. So it's going to be about absolute value inequality and the graph, comparisons, transformations, and also more coming up. The parent graph that you need to recognize for transformation. Okay, so just stay tuned. So I'll see you guys next time. Take care.